Section 4.3 is about point-slope form. This is another form of writing the equation of a line, just like we wrote equations previously in slope-intercept form. So again, this is another form out of 3 that we're going to see how to write the equation of a line. We started with slope-intercept form, now we're going into point-slope form, and then later we are going to do standard form. So to get started with point-slope form, I'm going to do a little problem to lead us into it. The first example says, consider the line that passes through the point 2, 3 with a slope of 1/2. Let xy be another point on the line. The first thing says, write an equation relating x and y using the slope formula using the 2 points. So step 1 is to write the slope formula. The slope formula is m equals y2 minus y1 over x2 minus x1. Step 2 says substitute in known values. I know that I had a point of 2, 3, a slope of 1/2, so that's my m, and I have another point x, y. So again, I'm going to substitute 2, 3, which is an x and a y, and I also have this other point x, y, and I have a slope, an m, of 1/2. So I'm going to plug all of those in to the formula that I was given. So it'll look like this. Instead of m, now I have 1/2. Instead of y2, I'm just going to make that just a y from this point, x, y. I have that y, so I'm putting y in for y2. I have my other y value, which is 3. So I'm going to say minus 3. So I'm putting 3 in place of the y1 over, in place of the x2, I'm going to put my x from the other given point that I was given, minus the x value from the 2, 3, which would be 2. So again, I substituted in the known value. So I ended up with 1/2 in place of the m, y in place of the y2, 3 in place of the y1, x in place of the x2, and 2 in place of the x1. And again, I got all of these values from the given information that I got from the problem. Step 3 says use inverse operations to eliminate the division on the right side of the equation. So inverse operation just means if I want to undo addition, I subtract. If I want to undo division, I multiply. So again, this problem is saying I want to eliminate the division. So I'm going to end up multiplying. So they want me to eliminate this division right here, because this literally means y minus 3 divided by x minus 2. So in order to get rid of that, I am going to multiply both sides times x minus 2. If I multiply by x minus 2 on the right, I need to multiply by x minus 2 on the left. So I would end up with, and it would make more sense when I write this if I put the 1/2 in front of that x minus 2. So I'm going to write it as 1/2 times x minus 2 equals, these are going to cancel, so I would end up with y minus 3. Step 4 says flip the equation around so that the y is on the left side. So I'm simply just going to put y minus 3 equals 1/2 times x minus 2. And oddly enough, this is an equation of a line in point slope form that has a slope of 1/2, just like it gave me here, through the point 2, 3, where I put the 2 right here and the 3 right here. So again, we just wrote an equation in point slope form of a line with a slope of 1/2 and going through the point 2, 3. So again, this is point slope form. And I derived this from the slope formula. So we're going to use this idea here in the next slide to develop the formula for point slope form. But notice we take y minus the y coordinate that we were given. And remember, y is always in my equation, just like y equals mx plus b. Y was always in the equation. So again, I'm taking y minus the y coordinate, which was 3, equals 1/2, which was the slope, times x minus 2. The 2 was the x coordinate of the point that I was given. So it's always going to be y minus the y coordinate equals 1/2 the slope times x minus the x coordinate, which was 2 in this case. And again, just like with the y, we are always going to have an x in the equation. Just like we had y equals mx plus b, we had x and y always in the equation. I'm always going to have x and y in a point slope form equation as well. So again, using what we saw in the last slide, we can derive the formula for point slope form of a line through a given point with a given slope of m. So you are always going to take, and this is something I would write down for sure in my notes. Point slope form is y minus the y coordinate that you were given of the point. So in this case, the point I was given was x1, y1. So it's going to be y minus the y coordinate of the point that I was given equals m times x, which is just the variable x, minus x1, which is the x coordinate of the point that I was given. So again, it's y minus the y coordinate of the point I was given equals m, which we know how to find m, either y minus y over x minus x, or like rise over run, times x is just the variable, minus the x coordinate of the point I was given. This x and this y will always stay in the equation. This y1 and this x1 should be replaced with numbers of the point that you were given. So for point slope form, you use it when you are given a point and a slope. Just like with slope intercept form, I would use it if I was given the m and the b. Y equals mx plus b. I would use it if I found the m and the b. I can use point slope form if I was given a point and a slope. So we're going to use this equation throughout this entire section. And honestly, once you get the hang of point slope form, I would say, even though it looks kind of confusing right now, I would say that this will be your preferred method because it's actually easier. I would say the hardest part about point slope form is just remembering what the formula is. Once you remember what the formula is, it is easy peasy after that. Let's move on to some examples. Example number 1, write an equation of a line in point slope form. We are going to see 4 different examples of doing this so we can get the hang of it. So again, we are told to write the equations in point slope form. So it wouldn't hurt, and I would do the same thing in your homework, it would not hurt just to write what point slope form is at the top of your paper, so you're always having it to refer to as you are writing the equations. So again, it is y, the variable y, minus the y coordinate of the point that you're given, equals m times x, the variable, minus x1, the x coordinate of the point that you were given. So for part A, we are given the slope of -3 and a point of 6,1. So we have a point and a slope, so it makes sense to write it in point slope form. So we would have y minus the y coordinate of the point that we were given is 1, so y minus 1 equals m, which we were told is -3, times x, the variable, minus x coordinate of 6. And believe it or not, this is your answer. You do not need to do anything to this equation. This is the equation of a line with a slope of -3 through the point 6,1 that is in point slope form. So this is your answer. You don't have to do anything to it. Part B, we are told we have a slope of -2 and it goes through the point 5, -1. So again, I'm using this form for point slope form to write the equation. So I would start off with y, the variable, y minus the y coordinate of the point that I was given. So the y coordinate is -1. So I'm going to say y minus -1 equals m, which was -2, times x minus the x coordinate of the point, so x minus 5. The only thing I would do to complete this problem is just change this to +1. Let's move on to part C. It says we have a slope of -1/3 going through the point -6, -4. So again, I was given a point and a slope, so it just makes sense to use point slope form in order to write this equation. I start off with the y variable minus the y coordinate, which is negative 4. If it makes sense to you, go ahead and just start changing that to just plus 4 from the get-go, equals m, which is negative 1/3, times x minus the x coordinate, which in this case is negative 6. So again, you can go ahead and just change that to plus 6. And again, this is your answer. You don't have to do anything to it. This is your answer in point slope form. Part D says we have a slope of negative 1 and it goes through the point 0, negative 9. So we have a point and a slope. So let's write it in point slope form. We start off with the y variable minus the y coordinate. In this case, it'd be minus negative 9. So I'm just going to go ahead and change that to plus 9 from the very start. Equals m, which is negative 1, times x minus the x coordinate, which is 0. So you can do a little simplification here, and you could write it as y plus 9 equals, since x minus 0 is just x, I could simply just write this as negative 1x on the right-hand side. I would accept either answer as an exact answer, as a correct answer. So again, this is writing equations in point slope form when you're given a point and a slope, just like you were given in each one of these problems, a point and a slope. Example number 2, graph the equation y plus 2 equals 2/3 times x minus 3. So from the get-go, I can see that this equation I was given is in point slope form because I have parentheses. That's kind of your first clue that this is in point slope form. Notice that the y is not by itself and I have parentheses in my equation, just like I do in the standard form of what point slope form is. I always have parentheses. So that's kind of a rule of thumb that you can use in order to figure out that you're given equations in point slope form and not in a certain other kind of form. So knowing that this is in point slope form, I can identify the slope and the point that I'm given. It's easy to identify the slope. It's always the number in front of x, just like it was in slope-intercept form. Just in this case, there just is a parenthesis also in between the m and the x. But again, it's just the number in front of the parenthesis or the number in front of x. So I know the slope is 2/3. The point is kind of a little bit harder to identify. Remember that in the standard form of what point slope form is, it's always x minus whatever the x coordinate of the point is and y minus whatever the y coordinate of the point is. So keep that in mind. Even though you see this as x minus 3, in the original form it's x minus the x coordinate. So in this case, my x coordinate is actually 3. And for my y coordinate, originally this would have been y minus negative 2, and it changed to plus positive 2, so that means my y coordinate was negative 2. If this doesn't make sense to you, just kind of remember that if it says minus 3 in point slope form, it's going to be positive 3. If it says plus 2, it's going to be negative 2. It's always going to be the opposite of what you see in your equation. And again, that comes from the fact that in the formula for point slope form, it's always x minus the x coordinate and y minus the y coordinate. Just like in slope-intercept form, I have to start from a point that I know is on the line. Like in slope-intercept form, I have a starting place on the y-axis where the y-intercept is. So that's what I graph first. So for point slope form, I start with plotting the point. The point is 3, negative 2. So I'm going to start by going to the right 3 and down 2 in order to plot my first starting point. So again, right 3, down 2. So you can see I plotted that point, 3, negative 2. I went to the right 3 and down 2. Now starting from this point, I'm going to use my slope just like I always do as rise over run. So I'm going to go up 2 and over 3. So starting again from that point, I'm going to go up 2, 1, 2, and over 1, 2, 3, and then put my other point. And there's my other point. 2 points determine a line, so I'll just connect these 2 points with a nice straight line, and there I will have my graph of the equation y2 equals 2/3 times x minus 3. And that would be my answer. A nice straight line through 3, negative 2 with a rise over run of 2 over 3. If this wasn't quite clear to you, you'll see in the next slide another example. So here it is, example number 3. Graph the equation y minus 1 equals negative times x minus 2. So again, I can identify this as in point slope form because y is not by itself and I have parentheses in my equation. Remember, the number in front of x, or in this case in front of x and in front of the parenthesis, is your slope. So if I have just a negative sign, that's implied to be a -1. So my slope is -1. When I graph, I always want slope as a fraction, just like it used to be when we were doing slope-intercept form. So I have a slope of -1 over 1. And the point would be your x coordinate and your y coordinate that you have in the problem. Remember, it's x minus the x coordinate and y minus the y coordinate. So when I see -2, that means my original x value was actually just +2. And when I see -1, I know that it was y minus the y coordinate of +1. So my ordered pair was 2, 1. And remember, if you get confused on that, just remember it's always the opposite of what you see in your equation, since in the original formula for point slope form, it's x minus the x coordinate and y minus the y coordinate. So just remember, always start with the point. So we're going to start plotting 2, 1. So that means I'm going to go to the right 2 and up 1 and plot a point. And there's my point, 2, 1. And then starting from that point, I'm going to go down 1 into the right 1 using my rise over run. So again, starting from this point, I'm going to go down 1 into the right 1 and plot my other point. And since 2 points determine a line, I'll draw a nice straight line through those 2 points to get the graph of the equation y minus 1 equals negative times x minus 2. Example number 4, write the equation of the line that passes through the given points in point slope form. So remember, in point slope form, I need to be given a point and a slope, or a way that I could find the slope. So if I was given 2 points, I can use y2 minus y1 over x2 minus x1 to find the slope first, in order to then write the equation in point slope form. So let's start with that. So for part A, I have the points 0, -6, and 4, 9. So I'm going to start by finding the slope, because no matter what, when in doubt, find the slope. So that same rule applies just like it did when we were in point slope form. If you have no idea what else to do, start with the slope. So I'm going to start with this 9. If I have 9 minus -6, since I started with a 9 on top, I'm going to start with a 4 in the bottom. So 9 minus -6 is 9 plus +6, so I get 15, and 4 minus 0 is 4. That is in lowest terms, so I'm going to keep my slope as that. Remember, point slope form is y minus the y coordinate equals m times x minus the x coordinate. Now notice I was given 2 ordered pairs, so I need just one of them to put in for the x1 and the y1, and it doesn't matter which one you use. I could use the 0, -6, or I could use the 4, 9. Both answers would be correct. So let's look at what both of them would look like. Y minus the y coordinate, so let's use this point first. Y minus the y coordinate, which is -6, so that would change to +6, equals m, 15 over 4, times x minus 0. And again, you don't really need to write that x minus 0, and it doesn't matter if you do or you don't. That would be my first answer. If I wanted to use the 4, 9, it would be y minus the y coordinate of 9 equals 15 over 4 times x minus 4. You don't need to write both of them. You just need to write one of them. I'm just giving you both options. But again, you only need to write one of them if this was a homework problem. Let's move on to problem B. We have a point of 3, 1 and a point of 1, 9. Remember, if I'm supposed to write this in point slope form, I need to have the slope. So I'm going to start off by finding the slope. When in doubt, find the slope. So let's start with this one this time. So I have 1 minus 9. Since I started with the 1, I got to start with the 3. So 3 minus 1. 1 minus 9 is -8. And 3 minus 1 is 2. -8 divided by 2 is -4. So I have the slope, so I'm going to put -4 in place of the slope, and I'm going to pick one of these points to plug in for the x1 and the y1. I'll pick, let's say 3, 1. So I'm going to do y minus the y coordinate of 1 equals -4 the m times x minus 3. And again, I could have had the same answer, or a correct answer, if I used the 1 and the 9. And both would have been correct. Example number 5, this is our last example. A school district pays an installation fee and a monthly fee for internet service. The table shows the total cost of internet service for the school district over different numbers of months. So we have numbers of months on the top, so 2, 4, 6, 8, 10, 12, and the total cost of the internet service, which is these big, huge numbers on the bottom row. Part A says, explain why this situation can be modeled by a linear equation. You've maybe seen some problems like this in your AMs. You can decide whether a linear equation is appropriate to model a situation based on looking at how the x values and the y values either increase or decrease. If your x values increase or decrease at a constant rate, like these do in this problem, how they're going up by 2 each time, so plus 2, plus 2, plus 2, if your y values then increase or decrease at a constant rate, then it can be modeled with a linear equation. So in this problem, you can see that if you add 3,428 to the 9,378, you get 12,806. If I add that same amount, 3,428 to the 12,806, I get the 16,234. And the same pattern follows with each additional number. I can just keep adding 3,428 and get the next number in line. So I can explain why the situation can be modeled by a linear equation by the fact that as the x values increase by 2 each time, the y values increase by 3,428 each time. So my final answer would be, as the x values increase at a constant rate of 2, the y values increase at a constant rate of 3,428. So again, this is my explanation as to why the situation can be modeled by a linear equation. And this should help you out with your AMs. Problem B says, write an equation in point-slope form so that the total cost is represented by y and the number of months is represented by x. So really that's just saying, write an equation in point-slope form and use x and y in your equation for your variables. So the first thing I need to do is find the slope. Remember, the real-world version of slope is rate of change, so we're trying to find m. Remember, when I'm given a table of values like I am in this problem, I'm really just given a bunch of ordered pairs. So all of these are ordered pairs. Our first one is 2, 9,378. Our second one is 4, 12,806, and so on and so forth. So if I want to find the slope, I just need to do y minus y over x minus x. So here's what I ended up with. I got 12,806 minus 9,378. I took these two values and subtracted. And then I took 4 minus 2. Since I used the 12,806 first, I used the 4 first in the bottom. So I know that 12,806 minus 9,378 was 3,428. That's what I figured out in part A. And then 4 minus 2 is 2. So 3,428 divided by 2 is 1,714. So there is my slope, 1,714. Remember, our problem asked us to write the equation in point-slope form. So I have my slope now. Now I just need to pick a point, and it doesn't matter which point I choose. Let's just use the smallest one. So remember, that's an ordered pair of 2, 9,378. So in my point-slope form, which I'm going to write on this line right here, I'm going to take y minus that y coordinate of 9,378 equals 1,714, which is the m, times x minus the x coordinate of the point, which was 2. And that would be my final answer for the equation. Part C asks, what is the installation fee? So the installation fee would be that starting amount. Anytime I think of starting amount, I think of slope-intercept form. I have an equation now in point-slope form, though. I can move from point-slope form into slope-intercept form by simply just solving for y. Remember, slope-intercept form is y equals mx plus b, where y is by itself. So I can go from point-slope form into slope-intercept form just by getting this y by itself. So the first thing I'm going to do is take this equation and I'm going to distribute, because in slope-intercept form there are no parentheses. So again, I'm going to take my equation and I'm going to distribute. I'm going to take this 1,714 and distribute it to the x and the minus 2. By doing so, I ended up with y minus 9,378, just like I started with, equals 1,714x, that's what I got when I distributed to the x, minus 3,428, which is what I got when I took the 1,714 times the negative 2. Next, remember, I'm trying to get y by itself, so I put it in slope-intercept form because the b is your starting amount, and this problem is asking for that initial installation fee. So to get y by itself here, I'm going to add 9,378 over to the right-hand side. I would add that 9,378 to the negative 3,428 since they are like terms, which I end up with y equals 1,714x plus, again, when I add this 9,378 to the negative 3,428, I end up with 5,950. So our B value is this 5,950. So our installation fee is this number right here. So the installation fee for the school to have this internet service was 5,950, and it would be dollars. And part D asks, what is the monthly service fee? So that would be the amount that you're paying every month, which would make me think of slope. We already found the slope as 1,714. So our final answer for part D is 1,714 because it's $1,714 per month. So again, that'd be your monthly service fee. And that's it for this section. I know this seems tough, but again, I cannot stress to you enough that the hardest part of point slope form is just remembering the formula. I wholeheartedly believe that eventually you will prefer point slope form over slope intercept form because solving for B is not a very fun thing to do. Notice when you do point slope form, you don't have to solve for anything unless you're not given the slope, which at this point should be pretty simple with doing the y minus y over x minus x, which we've done countless times at this point. So again, point slope form, y minus the y coordinate equals m times x minus the x coordinate. Eventually, I feel like this will be your favorite form of writing an equation. As always, write down anything that you don't understand so we can cover it in class before we move on.